Hello students, welcome back to my channel. Let us continue learning network concepts. So in today's session, we will be talking about different topologies with which we can arrange a given network. So the very first, so there are basically, we will be going to learning bus topology, ring topology, star topology, mesh topology, and extended star topology. More than extended, we will be learning about tree topology. So today's session will concentrate on bus, ring, as well as star topology. The other two topologies we will see in the next session. So let us start with the very first one. So the first one is a star topology. So what do you understand by star topology? So these topologies, whatever the name you are hearing, for example, star is nothing but that is the way that particular given network is arranged and it looks like a star. Okay, as you can see in this image, we have different computers arranged around and there is a hub in between. So this looks like a star. That is what is called as a star topology. So this topology consists of a central node to which all the other nodes are connected by a single path. Now, whenever I talk about a node here, it can be any network device. All right. So like I told you, there will be a central node to which all the other nodes will be connected and it forms the shape of a star. That is hence the name star topology. So it is the topology used in most existing information networks involving data processing and voice communication. So this is the very common network topology, what you will see when it comes to the voice processing, voice communication and data processing. So what is the advantages of star topology? The very first one is ease of service. Star topology has a number of concentration points where connections are joined. These provide easy access for the service of configuration of the network. Because I have a central hub, if I want to add another node or I want to delete an existing node, it becomes easier when it comes to the star topology because I do not need not do any other extra work. All I need is add, or if I want to remove it. Directly I can do that. Okay. One device per connection. Connection point in any network are inherently prone to failure. In the star topology, failure of a single connection typically involves disconnecting one node from otherwise fully functioning the network, which means to say, suppose there is a star topology and one of the node happens to fail. So if this fail, there is no harm to the other nodes. They will continue to work as it is. All we have to do is repair this. Until then, we need not hold to the other nodes. They will continue to do their work. So that is what one device per connection will help us do. All right. So that is about your star topology. The next topology, what we will be seeing is bus topology or a linear topology. So when it comes to the bus topology, as you can see, we will have a central line connection, okay, which is called as a terminator, and all the nodes are connected to this line, okay. Unlike our star topology, we do not have a central node here, and instead of that, we have something called as a terminator, which is a transmission medium going through in between the nodes. So this consists of a single length of a transmission medium, normally coaxial cable, onto which the various nodes are attached. The topology is used in traditional data communication network where the host at the one end of the bus communicates with the several terminals attached along its length. So what happens is every time this particular node wants to send if that particular node wants to send a data, then in that case, it will be sending through this communication line and of course it will have a receiver address. So whichever term that particular packet belongs to, that will fetch the data. Similarly, other nodes also communicate with each other through this line. That is how our bus topology works. So what is the advantage of linear topology or a bus topology? First thing is short cable length and simple wiring layout. So because there is a single common data path connecting all the nodes, the linear topology allows a very short cable length to be used. This decreases the installation cost. There is no much complexity in the network and also leads to a simple, easy to maintain wiring layout. Resilient architecture. The linear architecture has an inherent simplicity that makes it very reliable from a hardware point of view. there is a single cable through which all the data propagates and to which all the nodes are connected. So it is a very simple and clean architecture, hence it is easy to maintain as well. Easy to extend. Additional nodes can be connected to the existing bus network at any point along its length. So what do you mean by that? So every time I want to add another cable over here into this. All I have to do is add. I want to delete. I can simply delete it. Okay. So addition and deletion of the nodes is very easy when it comes to the bus topology. That is also another advantage. So then what could be the disadvantage? So disadvantages first is fault diagnosis is difficult. That is, although simplicity of the bus topology means there is a very little to go wrong, default detection is not a simple matter. Control of the network is not centralized in any particular node. This means that detection of a fault may have to be performed from many points in the network. Since in star topology, we had a central network through which we could find out where is the fault and everything. When it comes to the bus topology, there is no such system. Here, every independent system, there can be fault anywhere. So we're not talking about 2 or 3 systems here. We're talking about a network. There may be n number of systems connected. So fault diagnosis becomes difficult when it comes to the bus topology. Fault isolation is also difficult. In a star topology, a defective node can easily be isolated from the network by removing its connection to the center. If a node is faulty on the bus, it must be rectified at the point where the node is connected to the network. All right. Next is repeater configuration. When a bus type network has its backbone extended using repeaters, configurations may be necessary. When you are extending, okay, the central line, there may be configurations which you might have to do. Nodes must be intelligent. Each node on the network is directly connected to the central bus. This means that some way of deciding who can use the network at any given time must be performed at each node. Now, that is another problem. Like I told you, if at all a particular node wants to send the data to the another node, then there has to be certain communication protocols to be maintained where you will write the users to whom you are sending the data and who is supposed to fetch the data. What if all the nodes are using the bus? Then in that case, there will be a lot of confusions. Then who will decide who is going to use first? Who will decide who is going to use next? All those decisions need to be made. Another thing is, what if this entire bus line only collapses? If there is an issue with that, then that is also another problem here. Okay. So these are all the issues when it comes to the bus topology. Next comes as a ring or a circular topology. So unlike star, there is a difference between a star and circular topology. Okay. So each node is connected to 2 and only 2 neighboring nodes. So it is not that there is a central hub. They are connected to each other, 2 and 2, like this, like a ring topology. Okay, and transmitted onwards to another. Thus, data travels in one direction. For example, if at all you have decided that in your network data is traveling here, and suppose this is a sender, it wants to send data to this particular receiver, then data will come from here to here, then it will come from here, then it will come from here, which means it has to go through all the nodes which is coming in the path. All right. So after passing through each node, it returns to the sending node, which removes it. So once it is received, still the data will be going in the bus, but once it reaches the sender one, only sender one will delete that particular data from the network. It is important to note that the data gets through rather than travel past each node. This means that a single signal may be amplified before being repeated on outward channel. Node to node around the ring. After passing through each node, it returns to the sending node and removes it. So that is how a ring or circular topology works. Here, remember, we do not have a main transmission or communication line. We don't have like a bus topology, nor we have a central hub like our star topology. Here, each and every nodes are connected to each other and they will be transferring the data to each and every node. The data gets passed through each node in the network and then only it goes to the receiver. Also, once it reaches the receiver, it will be coming back to the sender and sender will remove it from the network until and unless it will be rotating in the network. So what is the advantages of ring topology? First one is short cable length. The amount of cabling involved in ring topology is comparable to that of a bus and is small relative to the star. Okay, this means that the less connections will be needed, which will in turn increase network reliability. No wiring closet space required. Since there is only one cable connecting to each node with its immediate neighbors, it is not necessary to allocate space in building for wiring closet. So, very simple connection is going to be happening between the nodes. Suitable for optical fibers. Using optical fibers offers the possibility of a very high speed transmission because traffic on a ring travels in one direction. It is easy to use the optical fibers as a medium of transmission. So that is what I said. If you have decided the data is going on clockwise or anti-clockwise on any direction, if you have decided the data is going to travel in that only, it is not that it has gone halfway in one direction and then it is going to come back. No. So in such situations, if you know the direction of your data transmission, then you can easily use optical fibers, and they are very fast and they are very reliable and less error, prone to errors. So these are the three advantages of ring topology. Now let us see what is the disadvantages of ring topology. Node failure causes network failure, of course. So because they are connected to each other in a node, through all the system, the data should travel. In case if there is a failure in one node, the entire network fails. Okay. The transmission of data on a ring goes through every connected node on the ring before returning to the sender. If one node fails to pass the data through itself, the entire network has failed and no traffic can flow until the defective node has been removed from the ring. Next is difficult to diagnose faults. The fact that failure of node will affect all the other serious implication for fault diagnosis. It may be necessary to examine a series of adjacent nodes to determine the faulty one. Since the entire network shuts down, we won't be able to, it is not easy for us to find out the defective node. This operation may also require diagnostic facilities to be built in each node. Okay, so that is another disadvantage. Network reconfiguration is difficult. If at all I want to add another system reconfiguration, if I want to do in this network, then it becomes very difficult. So it is not possible to shut a small section of the ring while keeping the majority of it working normally. We cannot do that. If at all you want to add another one, you have to shut the entire network and then only you can do any kind of a reconfiguration. So that is another disadvantage. So that's all in today's session, students. So we have learned three kinds of a topology today. That is a star topology, bus topology, or linear topology, and the last one is a ring topology. I hope this is clear. So thank you for watching and keep learning.